Maybe.
Hey there, everybody. Welcome back. If you've joined us before, but if this is your first time with us on the SBAU Astro Hour, well, welcome in first timers. My name's Ronnie Heron, retired local radio guy, your host for the weekly vlog program right here on YouTube that covers virtually all aspects of cosmology. Astrophysics are us, boy. It comes to you from the Santa Barbara Astronomical Unit, SBAU. At Santa Barbara, California's longtime telescope and astronomy club, based up at the beautiful Santa Barbara Museum of Natural History. You are invited to come join our club, just 20 bucks a year, or come hang out with our eager and enthusiastic members till you might be ready to join. Our meetings are normally first Fridays of the month at the museum, where we then meet a week later outdoors at night for our second Saturday star parties. Otherwise, everything's happening this coming weekend, including the man I'll introduce you to who's going to run the show, Professor Wilson, in a minute. Here's our four main topics today. There's an asteroid out there called, I think it's 44 NISA, NYSA. Do they spell it, pronounce it, Jerry?
Yeah.
NYSA. Sounds like an acronym for something in New York. We've known about it for some time, 1857, but not much about it. Now we're learning it's not only bilobed, it's trilobed. Oh my God. We're going to try to focus on a globular cluster that's magnitude 5.6 up in Serpens, the good old M5. Get this, on Wednesday, a couple days away, mankind's going to create its very own brand new crater on the moon's surface using one of Elon's rocket parts. And a week ago, I saw this story in the New York Times and was going to use it as an Astro Hour breaking news, but I decided against it last minute, thinking, this is more about art than about astronomy, so I'll shelve it. Now here it is, part of the talking points. It's an aging American sculptor named Charles Ross. Just finished his 11-story high star axis.
Oh,
Oh,
that's
that's
neat.
neat.
That's
Yeah,
neat,
it's in
Jerry. So
eastern
you
New
did
Mexico.
it.
I read about it. It's up on a big mesa, eastern New Mexico. Modern day ancient observatory. We got lots of pictures. So let's meet the gang, including the man who's going to deliver our speech this Friday night. Ladies and gentlemen, club president becomes a weekly professor of astronomy, Jerry Wilson, lower right of my screen.
Good morning, and good morning, Joyce, and my grandkids, Riley and Calvin, and to my lovely wife, Pat.
Okay, well, unless they're in the peanut gallery next to you, are they watching us, you think, Jerry?
Sometimes Pat's watching it downstairs. Yeah, every now and then they watch
Okay,
it.
good.
One time, my son sent me a picture of Riley pointing at me on his TV screen up in Oregon. Grandpa.
You
Pretty
got a
good.
family, I got to tell you, you're always doing something or getting stuck in a train or something on your way to Oregon and can't go and you got to turn around. We're missing our outreach guy. He's MIA, missing in action at the eye doctor, but he may join us halfway through. So, in his absence, I'm appointing Tom Whittemore, our beloved
Uh-oh.
newsletter editor and retired Westmont College professor. I'm appointing him our fact checker
Uh-oh.
and will correct Jerry if he ever
Pretty
picked the
good.
wrong name for a star or something. It happens.
Did you
And
like
then,
the, did you like my comment, Ronnie, about now it's up to Jerry and Tom to correct us?
Yeah.
yes, I
Yeah.
did. Well, I think we can handle it without him, but he may join us halfway through. Tom is married to Maureen. Tim Crawford, a lens expert and future speaker, December 4th. Going to talk about how many questions, the three questions you get asked most at star parties, Tim Crawford, right?
Yeah, that's gonna become like about 12.
Well, what? Give me one of those questions.
The be I think one of the ones that comes up a lot, you built this? How did
Yeah.
you do that?
That's not a question.
A character like you that could be on Archie Bunker's place built this? Are you kidding me?
We had a on what and up at Refugio last Friday. There was a really interesting guy, and I was sitting there telling everybody, I said, this is one I built, but it's really nice to get these sea stars because they're really compact, small, and easy to set up and use. And the man I was talking to really asked me a lot about how I built my little 8-inch Dob. And after talking to him for a long time, he said, "I'll take yours any day." He said, "Your talk was really interesting." And it's a comment that I will make at the end, Ronnie, about why it's good to keep this art alive of trying to make scopes. It's
Tell,
important.
tell me about those trips to the state parks. Do they post it at the gate during the day or a week ahead that we're going to have telescopes on the beach
No, he'll
that
come.
night?
That'd be one for Chuck, and sometime we'll get him to talk about that because he does a monthly. He sends out a monthly email to the people that are kind of the usual suspects, and then in those he lists all the different places he'll be for the month. So he goes month by month.
But I'm imagining you don't get the same crowd as you get on a Sunday at the museum looking at the sun.
Oh, we get a variety of crowds and variety of people from all over the world, and very interesting people all the way to kids that can't keep their fingerprints off your eyepieces.
A couple of years ago, it seems like they lost their palm trees at Refugio, didn't
They
they?
did. They did.
Did they
The
replace
ocean took it back.
Yeah,
Did
they try to keep that place going because that place many times you go up there and there's a sign hanging on the front kiosk saying campground full, and it is.
So that list of monthly outreaches is available to view on our website at sbau.org. Not .com, but .org.
I know, but I'm imagining a lot of the people that pull into that campground have no idea about us. But I hope
A lot of people do, Ronnie. They've been up there before.
Yeah.
Really?
I also, Ron, I post the upcoming outreach on every newsletter.
That's right. That's right.
So it's also there.
I
We
think,
also go to Carpinteria State Beach, don't we?
yes. I think
Yeah,
that
but
Refugio is the place, Ronnie, where Chuck does a July 4th viewing up there at Refugio, I believe. And every year he said there's these usual campers up there and they put on parades and then their own little July 4th celebration. So that a lot of return people know about us and come over and see us. Well, I think
my
we had
best.
100.
Those
I think we had 118 last Friday.
those little campgrounds that are right on the coast up here are wonderful viewing sites because the air over the ocean tends to have laminar flow instead of turbulent flow. So the seeing, that is the wiggling of your image, is very good. It's almost non-existent. And the sky is very dark because there are no cities out in the ocean to have light shining into the sky. So
Sure.
they turn out to be very, very good viewpoints, especially for planets.
They're incredible.
El Cap is a little inland, isn't it? You don't set up on the beach
Nope,
there.
it's right on the beach.
Yep.
Is it really?
It's
I thought it was
closed.
up in the-
It's
thought it
closed
went
for
into-
renovation right now, but we did a few up there last year. But I think that the one up at Refugio is just a little bit better because it's got a really friendly, flat parking lot that you can set up right there next to the water. It's really, really neat. And sometimes on a moonless night when the air is really steady and you're looking out over that ocean in the summer, you're getting Scorpius and Sagittarius. And Sagittarius looks like a big teapot, and the edge of the Milky Way looks like steam's coming out of the spout of the teapot and going overhead. It's really fabulous.
And that steam contains the center of our galaxy.
Yep.
Can't see the center of a galaxy, but you can point in the same direction.
I was never told as a young kid, what the hell is that big fog bank across the sky?
We need to get Jerry up there because he's got details that, Chuck is good, but Jerry's got some of the stories that go a long way. And it'd be neat to get him out there again.
Okay, here's what happens as we go to the silly science cartoons that are
I like
forwarded to
this.
us.
This is a great one.
Yeah, if you're going to paint a white picket fence black, make sure you finish the few fence slats you're working on before you hand the job over to your AI robot assistant, or he'll just repeat what
This
you
is this is reflecting back on exactly what happened when computers came on the scene, and the phrase "GIGO," garbage in, garbage out,
Yeah.
became popular. the computer will do exactly what you ask it to do, even though
Yeah.
you may not be aware of what you actually ask it. So the AI is the same thing.
That's
Isn't,
so true.
That's really
isn't
good.
isn't there a scene in Tom Sawyer about Tom giving the job of whitewashing the fence?
Yes, conning
Yeah.
his friends into whitewashing the fence.
Well,
Right.
The
Ronnie,
robot, but
on astronomy days, I used to go out to the big box area and I would demonstrate mirror grinding, and I'd get the kids to grind my mirrors for me.
Yeah,
Right, right.
all
Yeah.
right.
And Ron, that reference to Tom Sawyer, remember, he kind of tricks his friends into thinking it's a real privilege to whitewash this fence.
yes.
And so
Exactly.
he gets all kinds of coins and things like that. Okay. You know what the
Did you,
first word of Tom Sawyer is?
No.
Tom. So his aunt is screaming at him,
Yeah,
Tom.
that's right.
Yeah. The last word
doesn't
in the book, Jerry? Tom.
Huh.
Oh, interesting.
Nice
Mark
little fun
Twain?
fact.
Okay, well, this is Excelsior, a little different version of the ancient myth involving King Arthur. You want to go through this, Jerry? What's
Oh,
going
this
on?
is just showing a cursed connector, number 158, the Arthurian plug. Unfortunately, it can only be unplugged by a rightful heir to the British throne.
That's right, and they're both plugged into a wall
If you've
somewhere.
ever looked through all your collection of cords and plugs and stuff, trying to fit something that was in vogue 10 or 15 years ago, you feel like you found one of these.
Yeah.
My understanding, it was a rock, not an anvil, that it was stuck in. All right, here's some talking heads. A couple of scientists. These are stick figures. She's got a ponytail. He's got a bulb head, and
Yeah.
accepting their award. Tom Whittemore, you want to go through this one? Read it to us.
Sure, sure. Yeah. This year's Nobel Prize in calibrating your equipment carefully and not embarrassing yourself by publishing spurious results goes to Dr. Adams and Dr. Smith, who did not announce the discovery of microbes on Titan. Thank you. Thank you.
Yeah, there was a
Something
story
I'm
that went
missing?
around like that, but at first it reminded me of the fiasco from Gran Sasso in Italy, where they claimed their equipment showed them that neutrinos traveled faster than the speed of light.
Yeah, right.
And that's
Really?
sort of a physics joke where a neutrino walks into a bar and says, "Hey, why is it so dark in here?"
Yeah, right, right.
Oh, yeah.
All right. Do you want to describe this, Mr. Crawford?
Yeah, this one's kind of unusual. It's bad news. NASA accidentally shrank Earth's latitude and longitude lines in the wash. Kind of like it's like I don't know how they got the Earth into the washing machine.
Oh, it's
Yeah.
just the lines.
Yeah.
Well, here's the one somebody called attention to. It was you, Tim, right? Or was it
It was
you,
me.
Tom?
It was Tom,
me.
yeah.
Yeah.
Well,
Yeah, no, it's because, a lot of people not born around the time Jerry and I were, and you and Tim would know this, that, Buffalo Springfield was a wonderful rock and roll group, the late 60s. And I listened to them a lot. And the
sure.
reference right there is to one of their tunes.
That's funny. And
Yeah,
that's
there's
got
something
to be a real
happening
sign
here.
somewhere. Probably where New York.
This was written right after the Ohio protest shooting where 4 people died.
Yeah, Kent State.
He
Oh,
says
no
there's
kidding.
something happening here. What it
Right.
is ain't exactly clear.
Yeah.
There's a man with a gun over there, et cetera, et cetera.
Telling me to beware.
Yeah, that's
Yeah,
right.
and that was a real famous Buffalo Springfield song. And
I think
those lines,
I think it may have been their first album, Jerry.
Could be.
Well,
Yeah.
yeah, it was on it. Buffalo Springfield is a name of a rifle, though, right?
Back in the 1800s.
Yes.
I had a hard time until I finally got this.
Yeah, they're stuck on a desert island.
Yeah.
You want to read it, Tim?
Yeah. Lucky for us, the cartoonist is a lousy speller. You know what? I
It's
think I
a
spell this word wrong all the time.
dessert.
Instead of a
It's a
desert
desert
island.
island.
Instead of a desert island, it's a desert island.
Right, 2 S's. 2 S's.
So
Two
how to
S's
remember the difference.
is the desert like sand desert?
A
Yeah.
desert is 1 S.
Yeah.
Dessert is 2 S's.
The mnemonic to remember it is which one would you rather have, desert or dessert? That's the one you get 2 of.
Yeah.
Well, this when you gain weight, believe me.
Oh,
Okay,
okay.
Jerry, read it to us.
I was told technology would eliminate unnecessary work. Instead, I now have 60 passwords, 13 verification codes, and a robot asking me if I'm a robot.
Yeah.
I just clicked on that box recently. If it were a robot, couldn't he lie?
Uh-huh.
All right, you're definitely gonna, or somebody's gonna have to get through this.
This one I don't get.
This is a bingo
The
card.
bingo card, Tim.
So
Oh, is
when
it really?
your
I
Rubin
it is.
Observatory makes any of these discoveries, for example, when it spots Planet 9, you get to put an X there. When it gets a Mars-sized trans-Neptunian object, you get to put one there. So it's full of all the discoveries maybe about to be made.
Yeah,
Oh, okay.
Defunct
Okay.
spacecraft isn't one of them.
right.
Isn't it when you get bingos that you get one in a line or
You
one
get
across?
everything in a line there,
Oh, yeah.
there, or diagonal.
Yeah, last week, Jerry, so Maureen and I go to Chrissy's little classes over the planetarium, and she just opened up a whole basket of some of the first pictures from the Vera Rubin
Oh,
telescope.
those are
Was
very
really
impressive.
neat. God Almighty, can that thing see stuff? It's just amazing.
Is it better? Is it better than the James Webb?
It's a different type of telescope, so it's basically a wide field camera.
Yeah, the James Webb goes deep into infrared,
Yeah,
but it's a narrow field of view comparative. This is a super wide field of view.
right. Yeah, so one of it takes an image every 30 seconds, okay? And on each of these images is 7 times the size of the full moon. So it's like 3.5 degrees by 3.5 degrees. They're huge.
Yeah, it's a good
Terabytes
area.
of data, terabytes of data, you know.
Now this is a takeoff on a very common type of joke in the aerospace industry I worked in. Only it was called bullshit bingo. And you had a card like this, and you had all the key, phrases that were in corporatese, like dual use and run it up the flag and see who salutes. Whenever you were in a meeting and you heard what some of these talked about by a corporate aficionado, you'd have this card, and when you got bingo, every now and then you could hear someone yell bingo. Card full of all
That's pretty
stuff.
good.
You know, technically, bingo is still illegal. It breaks the laws of lotteries.
I
Really?
didn't know that.
It has
No,
the
me
three
neither.
elements. It has chance, consideration, and prize.
Huh.
That's only supposedly legal in Vegas, Nevada. Okay, the lady is having it looks like dinner with who? Where's Waldo?
Yeah. I
Anybody
love
get
getting
that?
lost in a great novel. Oh, I enjoy being hard to find in a picture book.
Thanks to his red and white striped shirt, we can all get him in that damn hat. Yeah, there are big books probably sitting on your coffee table right now full of Where's Waldo?
When my wife went in for surgery a couple of weeks ago, they gave me a book in the waiting room because I was going to be a long time, and it was a Where's Waldo book.
Oh, that's
I
good.
suppose there are people that'll circle him so you don't get to look.
Yeah,
How's Pat doing, Jerry? Okay.
great. All done and done.
Good, good.
Well, that got us into the mood. So now we're going to talk hardcore stuff. Probably most of it's close to home this week.
By the way, that sun behind me that you
Mhm.
can see there, that was yesterday at the Museum of Natural History, and I just took it with an iPhone and did some pretty not very professional editing on it to bring up some of the features.
It's a great job because he's using a non-tracking scope too, you know.
Yeah.
Is this the crater on the moon we're going to make?
This is a crater that's about to be. Let's see.
Wednesday. I guess the whole world's going to, the whole planet that's facing the moon anyway is going to be looking at it.
Wait a second, I got to look at my notes and see what day this is. I think it's June or August 5th.
Yeah,
Okay.
so it's Wednesday, 5th, right?
August 5th.
Yeah, and I think that we've got a little bit of confusion because I think Joe Doyle sent out it's going to be Tuesday, and I also heard it's Wednesday.
Yeah, it's Wednesday the 5th.
Yeah, and Chuck sent around a note saying that for us here, just for your information, about 11:35 at night,
Okay.
and it's too low for us to see here.
Hmm.
Too low. What does that mean?
It means it's too near the horizon,
Yeah,
and
it's a
it's not going
challenge
to
for
be
us.
very observable. The east is probably going to get a better view.
Okay, but it's part of one of Elon's rockets.
Yes.
This is the second stage of Elon's, what was it? The Falcon 9 launch of the Firefly's Blue Ghost lander to the moon on
SpaceX.
January 15th, 2025.
Hmm.
It was on board the same mission that launched the Hakuto R mission 2, called Resilience, a robotic lander developed by the Japanese company iSpace.
Really? Not part of an Artemis mission.
So it's going to hit here, and this is a model that they did of what the dust plume and the explosion should look like. The amount of light, it'll be a flash of light, and it will be the plume should be several orders of magnitude brighter. The order of magnitude is time 10. So it should be at least 2 or 3 orders of magnitude, between 100 times and 1,000 times brighter than the background moon for the first few minutes after impact. This is what their models suggest for 190 seconds after impact. This is altitude above the moon. It's right on the edge of the moon when you're looking. And these craters up here, we'll see in a minute what they are. But here, this is target particle plume density, and then they estimate the brightness from that. But it should be here in this range of 1 million per square meter as you look at this. So it'll throw up a lot of dust. It'll settle back down. And you see it, report it. This is a picture of the second stage at the SpaceX factory. And this is the thing that's going to hit. Now, these things here are just holders for it. They're not part of the spaceship. It's this white thing. And it's largely an empty container. You can see one over here from the end. So it's not that solid of an object. It's going to collapse mostly. And
Won't pulverize and vaporize it. There'll be metal left on the moon.
going to smashalize.
Specialize. Okay.
And
It is,
why does he want to do this?
You what?
Why does he want to do this?
Guess you have no choice.
He didn't do this on purpose.
Oh, I see. So it's just headed to the moon.
Yeah.
Left over.
Oh, okay.
Yeah.
The Lunar Reconnaissance Orbiter will be passing over the projected rocket site crash about 7 days prior to the impact and about 7 days after the impact. So we will be able to see the crater that results.
From what I understood, Jerry, they said online that that this happened before intentionally, and that the plume that rose from the first time something hit the moon, it gave them evidence of water ice on the moon. So it led to that discovery.
Okay.
And they're hoping to make lemonade here. That's what the quote is. They make lemonade because this is a mistaken trajectory, and it just so happens that they're going to guide it, or it's guiding to the moon.
But the Japanese hired Elon Musk's SpaceX company.
SpaceX runs a service of launching anything you want into orbit, provided you pay for the launch. And everybody wants to do it with Elon's equipment because it's highly reliable and it's less than a quarter of the cost of using an expendable rocket, not a reusable rocket. When his first rockets the reusability came up and effectively lowered the cost of space launches, Russia complained about the US government subsidizing Elon and taking their product away from them because we were using Russian spacecraft to launch our satellites because we didn't have a launch system of our own. NASA had been too underfunded. So when Elon came on board, at first Russia said it's not possible, don't waste your time. And now everybody is struggling to make reusable rockets. Japan just landed its first one, I think, and China did too, and India and Brazil, I think, and France are they're developing their version of these rockets too. So it's the future thing.
Yeah, it's
Well, is he
interesting,
making
Terry,
the
to see Mel Bartles has a crater named after him. That's kind of neat. You know,
Is Elon making the Artemis rockets?
Say what?
The Artemis project that's going to take Americans back.
That's a NASA project. That's where the
That's
NASA
it,
is
huh?
building and has been building for a long time their space launch system. And it is not a reusable system. It's quite expensive.
hmm.
I have always imagined, but I have no word on it, that there is a tremendous war going on between NASA and SpaceX, because SpaceX has basically leapfrogged NASA. So NASA has spent all of this money on building the space launch system, and Elon Musk just leapfrogged them. So they took away his flight permit until after the Artemis launches use up the space launch systems that they developed. So they
Oh,
don't.
wow, I didn't know that.
Yeah, well, that's my projection of what's going on behind the scenes. So we'll see. Now, this one is Einstein crater right here. You see, it's a crater within a crater. And this is the Einstein crater straight on, taken from the Lunar Reconnaissance Orbiter. So somewhere in this thing is going to be the hit.
Mm-hmm.
Now, this crater right here is called Carroll. And this is the crater that was made when the Artemis rocket ship crashed accidentally into the moon. And it produced it. And this was the first, was named after the wife of one of the Artemis astronauts. And that's right next to Einstein. It's inside the Einstein crater. So it's going to get hit again. And then this is Bell crater. So somewhere in the region of Einstein and Bell is where it's going to hit. And in this picture, what it'll look like from Earth, some parts of Earth, but not our part, you can see the Einstein crater here. But Bell crater is just on the other side of the moon. It's just past this ridge. So we can't see it from the Earth here, from Southern California at the time it's going to hit. But we should see the plume. And in this region, it's calculated to be just like this.
Well, who on Earth will be able to see it? What continents?
Probably Eastern America.
Yeah. And South America.
So there's no use us setting up our scopes anywhere, right?
That's what I understand from this morning's text from Chuck. I haven't verified anything, but he's usually right on the money.
Yeah.
11:30 at night. Is the moon going to be full? No, it's nowhere near full, is it?
No, it's actually
It's waning. It's waning now.
Yeah, it's waning, so it's going away. Probably near third quarter.
Yeah, it's heading for last quarter.
Mm-hmm.
But this side, the limb of the moon on this case will be visible, will be illuminated. Now, the next topic is the discovery of the first triple-lobed asteroid.
That means three balls together?
Three things together somehow.
Got it.
This is the clearest shot they've got, and this is taken by a telescope, a big telescope here on Earth that uses adaptive optics to take away the blur of the atmosphere. This is an asteroid called 44 Nysa, N-Y-S-A.
Right.
And let's see. This is a joint observation by the Large Binocular Telescope on Mount Graham in Arizona, and a very large telescope on Paranal Mountain in Chile.
We're looking at a round view of the heavens with all those dots, those white, that's
This is
stars.
just background noise, things that
Oh.
didn't, it's a cutting edge process. They're right at the ability of these telescopes to take away the wiggle of the atmosphere. And it doesn't completely take it away, but it clarifies the image a tremendous amount. Now, in addition to it being a triple lobed asteroid, it's got a moon.
Oh,
You're kidding.
So this asteroid is 47 miles in diameter at its widest point. That's this. 75 kilometers. And let's see, this one is a 6/10 of a mile diameter moon,
that's pretty big.
which does not have a name. So,
Not the one our outreach guy called it, is it?
No, no,
He discovered one. He's going to talk about it in December.
that's
along with
right.
Tim.
are we going to have a guy in December talk about NISA?
No, Jerry, Chuck's going to talk about his discovery of the moon around an
Oh,
asteroid.
yeah. Yeah, this is not his discovery of the moon, but he
No.
did discover a moon. So we're looking for the Chuck's moon to make an appearance here someday.
There's very specific rules about naming moons. It has to be associated with the person that discovered the asteroid somehow, but Chuck's
Yeah.
going to explain all that.
Hang on, I'm switching here.
Okay.
Makes me wonder what we should call them. Moonlets?
Um,
What happens if we find a moon orbiting something like that, and then the moon is big enough to have its own little moon?
yeah,
Reorbiting-
I think that's what Jerry referred to as the three-body problem.
No, he's talking about three lobes together, I think, on the asteroid itself. But I'm talking
No.
about
I
three
think a
orbits.
moon of a moon, though. A moon of a moon is like a three-body problem, and I think Jerry went into that one week.
Yeah,
I just don't
Just a
think we
second.
see them. That doesn't exist so far. I mean, I can remember years of not ever thinking about moons around asteroids. It just didn't happen. Now they're all the time, or at least several. And
You know, it's
what is
funny. I asked that very question years ago. Can a moon have a moon? And it was it's
It
now
can.
being talked about.
Yeah.
So and it's
And
what
Pluto's
Jerry
got
referred to, and I'm still not clear on it, but it's a three-body problem. So there's a little bit of
Yeah,
well, the three body problem is about orbits, I think, about three
yeah,
orbiting.
the orbital mechanics
it's
are
one case, one special case of a three-body problem. If you can see this video, it shows the asteroid rotating and it shows the moon over a short video.
oh yeah.
Huh. What's the NISA mean? NYSA, do they know?
I don't know. I suspect it's a Greek name.
I can try it. What is NYSA?
Yeah,
New York something or other association. Acronym. Fascinating stuff. And now doing Chuck's work of fact checking is Mr. Tim Crawford. All
okay,
right.
you can
It
see
says
this.
it's named after Nysa, a sacred mythical mountainous region from Greek mythology where nymphs raised the god Dionysus.
Oh,
Wow,
that one.
Yeah. Yeah.
that got us.
Uh-huh. So anyway, here we are looking at my two favorite stars in the sky,
Oh yeah.
Zubin El Ganubi and Zubin El Shamali. I used to go when I was a kid. My parents took me to see the planetarium show at the Griffith Observatory in the summer every month when they changed it. And what the lecturer one time was saying that a person had called and they had just had twin girls. They wanted some kind of a star name to name the girls. And he said, well, you can use my favorite star names, Zubin El Shanubi and Zubin El Gamali.
They're hard to say, Jerry. They're
Yeah.
hard to say.
I've never heard those that are on a birth certificate yet, but we'll see.
And Zubin is claw. So one's the north claw, one's the south claw.
Yes, these used to be part, you over here, you see the constellation of Scorpius.
Mhm.
There's today's claw version. And they used to be, the claws used to go out to here
Mhm.
and include these stars. But someone decided they needed to be a set of scales anyway. So when the association that names things met in 1926, they took the claws away, even though it's claws in Arabic, and shapes the thing. I met a guy at the gym the other day who's from England, and his name is
What are
Rakan.
the clones?
Rakan.
Oh,
And I thought, knowing star names and stuff, I wonder if that's Arabic for sun god, sun king, because Ra is Egyptian sun god, and Khan is the Arabic word for king. I got to ask him and see if that's the case. But
Yeah, interesting. Yeah. I would bet that it's exactly what it stands for.
anyway, what we're looking for here is in Serpens Caput. Up here is M5 right here. This is a globular star cluster, and it is the brightest star cluster in the northern hemisphere. The brightest one in the south is 47 Tucana, but we can't see that from here. So right here at about 10 o'clock at night, it's riding high. And this over here is it's not shown here, but it's off the picture, is Sagittarius with the center of the Earth, or with the center of our galaxy.
ooh, black holes
This
are
is an amateur picture.
Wow.
A guy named Ayoub, Ayoub, and this is this is Messier 10. Did I mean to put that in there? Oh, forget that. The 10 this is the 10th slide in the show. It's Messier 5 up there. And so this is the globular cluster, classic globular cluster.
Isn't this off the nose of the horse in Pegasus?
What's that?
That's
Isn't-
15. I think that's 15, Tim.
Oh, okay. Okay. Never mind.
Okay.
I want to find this one.
Well, are the numbers on the Messier's like a timeline of when he discovered them, or did he just start at one area of the sky and work his way around?
Oh,
be
good
the
question.
flip.
I don't know that. I don't know the answer. But it's definitely not an order of brightness, because M1 is the crab, which is a supernova remnant, and in a telescope it's just a smudge, hardly noticeable.
No, this is very dramatic. It's very bright. I think it's magnitude 5.6.
Wow.
Wow.
The naked eye, you could see down to 6 under a real dark sky, which don't work. Don't hold your breath. We never get those in Santa Barbara. If you look, this globular cluster is actually elliptical. Squint at it, and you can see that it's got a long axis here and a short axis here.
Like
Why
a
that
mini
is,
galaxy.
I don't know.
Black hole inside it?
What's that?
Black hole?
Possibly.
Ah. Well, that means some of
Trouble
those
is,
stars,
you can't see in there real well.
I know, but if there's a black hole anywhere, especially a supermassive one, the stars are going like crazy.
Yeah.
Might even be able to see them move, wouldn't you think?
If you could see in there, yes.
This globular is it says it's just about the same distance as the Hercules cluster M13, and hundreds of thousands of stars. But what I didn't know is that it's known for the really, really old stars, up to 13 billion years old.
Yeah. All globular clusters have that stars in them. Can you see this, or is this washed out?
We can see it pretty good. I think there's some of them that aren't. It's not bad, Jerry. It's not too
Okay.
bad.
Well, this up here is the main sequence. This is a Hertzsprung-Russell diagram for where stars sit. It shows their brightness down here, and it shows their color along here. And it shows that and this is surface temperature. This is goes up, and at this point, this is a turnover, and that shows if this were a brand new cluster, very young stars, these stars that would be up here on the main sequence have run their life cycle, and they've died and turned into other stars, other types of stars, red giants and white dwarfs. And that's these other stars that you see around here. This turnover point is indicative, it's a real low, it's indicative of a very old cluster. These are stars that have not run their life yet, but up here are the ones that have all expired in the previous 10 billion years and have turned into these types of stars. RR is a type of star, variable star, RR Lyra. This is red giant branch.
The orange ones, in my computer, the red is at the bottom, and then orange is right where
Yeah.
you had your cursor there, right there.
Yeah,
And
that's the RGB ones, the red giant branch.
okay,
These are stars like the Earth, Sun, which would have been up here in its youth, and then when it gets real old, it blows up and becomes a red giant.
Can I ask something about clarification on star clusters?
Yeah,
They're either stars that have always been in the Milky Way that decided to gravitate together and become a beehive,
no.
or they were a little captured.
They were something all by themselves that were in a globular cluster, maybe even the core of a small galaxy with its black hole that got absorbed or taken over by the Milky Way in the history of the universe, and now it rotates around the Milky Way. These are not in the plane of the Milky Way. They occupy a sphere around the Milky Way. And the globular cluster has been a globular cluster probably before the Milky Way formed. And it was captured.
Well, this doesn't look like the same lines I've seen in those other Russell.
Yeah, it's very similar. Where this turn here, this kink, if that would be way up here or non-existent, it means it's a very young star cluster. And that's mostly open clusters. I think we'll see one in farther down in the talk. But this fact that it turns here at this point shows that it's a very old cluster. All these stars in here have lived through their lives and aged, and they are in their death throes in one way or another. And that represents these kind of stars off here.
But Jerry, the picture you showed us at the beginning showing the cluster itself, it just looks like a ball of light. When we zero in on that with the best telescopes we got, your Webbs and everything else, can you pick out any stars in the middle, or do you just see white?
No, they have not resolved the core of this to my knowledge. But here you can see individual stars in it. I mean, right
well,
there.
on the edge, sure.
There's red giant stars here. These are the RGB kinds. You can take this picture and you can, in PixInsight, one of our processing softwares, it'll make a Hertzsprung-Russell diagram for you of whatever picture you take based on its brightness.
And to add something that what you asked, Ronnie, is with the globular clusters, and I've asked this of Chuck many times, is they get more dense. I always describe them as a snowball of stars.
Yes, that's right.
And so that as you go to the center, they get more and more dense. And that's why it's really hard to resolve the ones in the middle.
Right.
But any one of the stars inside, if they were out and about among the others that we have names for, they're just lost, aren't they? There could be giant Betelgeuses in there,
but they've named a lot of them. And this is where I think Jerry referred to him before. I'll let him discuss this because it's the blue stragglers, and he can describe that whole scenario.
We're talking thousands, right?
We're talking millions.
Millions.
Millions of stars. Good Lord.
Yeah, one that we looked at up at Refugio, and that's another thing about Refugio is it gives you a southern exposure that we usually don't get in town. And there's a globular there called M22. There's like at least 2 million stars in it.
Is
And
that right?
yeah, they're just packed with stars.
And each there are some in there that could be very distinguished by themselves if they were out and about by the lone, but they're
I don't
inside that ball and they're part of the M.
I don't think that's the point. I think the point is that there's millions. I even asked them, I said, do they touch? And the answer was no, but they get more they get closer. I mean, they just
And
get more dense
they're gravitationally held to the mass concentration in the center of the star cluster. And
there you
that
go.
it's a gravitational pull on all the stars you see that make up the cluster. It's actually a unit, and it's very hard to get out of. Some star clusters have gotten so old, and as they go around the center of the Milky Way in their circular orbits or elliptical orbits, for example, there's a what is that, Roche limit, and for these things. So these stars out here, let's just assume that the center of the galaxy is down in this direction. And so these stars out here, while they're orbiting this object, they are also orbiting the Earth's core. And these stars are farther away and these stars are closer. So they will have a slightly different orbit. And so what will happen is this stuff will get flung out ahead of the mass of the star cluster, and things down here will get, no, it's the other way around. Stars going this way will get flung out ahead of the star cluster traveling this way, and these will get thrown out behind it. And so that will give you a what's called a star stream, very faint star stream and very low density. But eventually, trillion years or something, this thing will evaporate because it is within its Roche limit from the center of the galaxy, of our galaxy.
Oh, okay. I got you.
But despite the fact that we're looking at a ball of millions of stars all moving around,
Like a beehive.
no two ever collide.
All the time.
Okay, when they do, is it like a nova?
Like a
Do
what?
we see it? Does it
No.
suddenly? It
Oh,
isn't. We
do you
can't
see a flash? If
Yeah.
you're looking right at it and you happen to be lucky enough to catch a star collision, you would see a flash. But you're not going to pick it up a week later or a week before. And so you don't know exactly when to take the picture. But there are stars like that all of a sudden they have surface brightness, temperature, and mass that are different from what they evolved as. And these are called blue stragglers because they're hotter than they should be. And blue is the hottest color to white up there. And so these stars all of a sudden become blue stars where there shouldn't be any blue stars. And they only happen by collision in globular clusters, and they're called blue stragglers.
There you go. That's it, Ronnie.
But
That's the part I was missing.
instead of them all being light years apart, they're what, light months apart, light days, light weeks?
Yes,
All
there
things,
are. They're
all
very,
kinds
some
of
of them are
stuff.
very close. There
Yeah.
are stars that are probably shaped like teardrops because they're too close to something else.
Whoa, geez. Fascinating.
Okay, now we're looking at a dwarf nova. This is the picture of this dwarf nova. These are, let's see. This is in Cassiopeia, and this was I wonder where that went. Let's see. Okay, well, we're just gonna go with this. This blue thing here is not actually a picture of the nova. It's a dot put on this photograph to show where the nova is, because right now it's too faint to be seen in this picture. But here in this picture, you can see the nova is bright here, and this is about the same. In a photograph, the star's size is an indication of its brightness. And here, this one is 13.4. They leave the decimal point out. in variable star studies. And this one is roughly 13th magnitude at its brightest. I think it actually goes up to a 12.9 magnitude. So it's about 13 magnitude. And you can tell that by the neighbor here with it. And then when it lasts a few weeks, and then it goes back to, this is the position of it, but you can't see the star there. That blue spot is just there to indicate where the thing is.
You're talking nova. That means an explosion,
Yeah, it's an explosion.
but it's not a super, or is it a hyper or a kilonova? Or
No, none of those. It's smaller than a kilonova. It's a dwarf nova, just as dwarf would imply. And this is its light curve. In November, 3 November 2010. These are different days. It does a Julian calendar, which is, for astronomy, they use a calendar where you can do simple math, adding and subtracting to find out the length of time between two events, which you can't do so well when you use the date, the regular our regular calendar. So these are the days from the beginning of the calendar. So this is 504,888 day. This is 830. So this is 50 days before this. And you can see these structures as this thing goes from 13.4 to up to 12. So it is a binary. Like a kilonova, it accumulates crap off of a big giant star that it's orbiting too close, and the hydrogen accumulates on the dwarf star until it builds up a big enough pile that it creates a fusion, a nuclear explosion, a hydrothermal, what is it? Anyway, a thermonuclear explosion. And here is at the peak, and then it eclipses gets eclipsed, goes behind its star, and then here it shows up as another explosion peak.
oh.
So,
Did you say 2010, 16 years ago this happened?
this is right down there. See, 3 November 2010.
So it's 16 years old. Is it going to leave a small nebula behind eventually?
That's a good question. It's sort of trying to. It's taking hydrogen off of a giant star, and when enough of the hydrogen gets down on this little star, which has a very dense gravitational pull, pretty soon it crushes the hydrogen together so much that the temperature rises and it starts fusion, and the surface of the dwarf blows up. It's not a lot of stuff goes because it's a very strong gravitational field, but it does produce this explosion, a fusion explosion, that qualifies it as a dwarf nova.
Well, I doubt you'll be talking about any Earth-like exoplanets going around those two this Friday night.
Nothing around there.
No.
It'd be they would only get to their first 4th of July light show.
Hey, welcome back, Tom. Those bathroom breaks are great, aren't they?
What's that?
Nothing. I was curious if you're having something built or torn down, or a bird is visiting in the backyard, or.
Oh, no, I was noodling around with my background. I lost it, so that's all right. I wanted to put another picture up, but I couldn't figure out how to do it.
Well, sooner or later.
This is kind of interesting
Tim
stuff.
sent these pictures of the structure that's being built in New Mexico. It's basically a type of it's based on the type of an astronomical instrument that was used and built in ancient times to mark the passage of the stars and the position of the stars. This large structure was used as an observatory to time things. It's in the same category of opticsless instruments as Stonehenge. So you just use a lot of fixed structures to see the Earth as the Earth passes under the stars. This is basically a way of looking, and up here you decide when the thing is passing a meridian point. So this is lined up with the meridian. And when it changes, then you become inaccurate. But this is a modern day one built, not the
Right.
ancient ones. But you can
Right.
find, go ahead.
I was going to say that the fellow who put this thing together started this when he was in his 30s. He's now 88. And this whole thing appeared in the New York Times, okay, about a week ago. And I showed it to Tim. I guess he flipped it to you.
I
Shot it.
did. Yeah, you're right,
Yeah,
Tom.
that's really nice. So this guy was doing this at a time when astronomical naked eye observatories were kind of in vogue, and there was money to support these structures. And among them is I put some pictures of the sun tunnels, and I think it was the July issue of the newsletter. The sun tunnels were made by Mary Holt back in the 1970s, and you can actually go to these things. It's really interesting. And so there's a whole host of these astronomical observatories around the world, and I've been kind of like noodling, with learning about each one. And so I'm hoping to put some of this stuff in the newsletter as time goes on.
Okay.
What's interesting about this one, you guys, is that it's not done yet.
No,
Right,
It's supposed to be done, I think, this year or early next year.
they have
right.
a fund. They're seeking the last $5 million to finish it.
Yeah, yeah.
The blurb I read had a notice down at the back that drop-in visitors are not allowed.
Yeah.
Yeah,
So you
that's
have to
right.
make a reservation to see this thing if you want.
I think it's very expensive too, Jerry.
Yeah.
If you want to, be there, it's very expensive. Um,
This shows the top up there.
Oh, that's a good image.
Stairs.
yeah, for some reason I am not seeing what you're showing, Jerry, and I don't know why.
Oh,
So
what do you see?
I'm seeing
I
it.
just see your face, and I see Tim's face now.
Oh no, no, you go up to view. There's a place that you can say, let's see, up above, I think there's the three dots on the top, Tom.
Oh, that again? Okay, go
And
ahead.
click that, and then you want the Prez's screen.
Okay. I don't want to interrupt this. I can't see that. So anyway.
Okay.
You're missing out. This is fascinating. Kind of looks like a pyramid in the middle.
Yeah.
Okay, I got it, Jerry. Thanks, Tim.
Okay, sure. Well, then the one that we just saw was this one, looking up from the bottom. Now we're looking up from here over to there.
Yeah. So Jerry, you must have pulled this information off of the website for this thing, huh?
I pulled it off of some website. I don't know.
Yeah. Yeah. These are really nice photos you got.
Yeah, these are nice images, Jerry.
Now, the
And
man's
That right there.
looking-
That one right there.
Yeah, looking straight up.
Yeah. And the idea is to march up those stairs, right? At
Yeah.
night. At night. Because it's pointed right to Polaris, right?
But what we're looking at is that he poured a lot of concrete, right?
Oh God, yeah.
Oh my gosh, yes. Yeah. And in fact, he started this thing by dynamiting the area. And it's up in the high plains of New Mexico, as Jerry said.
There you have it right there. What
That is it.
he had to excavate the hillside it was on. He decided that he had to go down, Ronnie,
That's
into
right.
the ground.
Well, is it going to be useful someday? Will we learn stuff?
It's an art project. These types of instruments
Yeah.
are of historic interest, but they're not of scientific interest nowadays.
Right.
I think what he was trying to do was, as you walk up these steps towards that little oval, the little hole,
Mhm.
you're getting closer to it. So as you get closer to the little hole, the image, the sky
Expands.
expands as you get
Mhm.
closer.
Yeah.
And so you're seeing images, larger and larger images of what you can see with a wider and wider lens, wider and wider view. And as you back out, now you're looking through a soda straw.
Right.
So it's designed to give you different looks of the night sky.
Right. And there was an effort at one time to put money into this thing from Congress, but I think from Congress. But what happened was it was viewed too dangerous to walk up these steps in the dark, without any kind of a clasp, a handrail or something like that. I think he's trying to put in handrails now.
Yeah, he probably will, Tommy. It's just
Yeah.
you know, that if the government gets a hold of it, look out, because they'll put so many safeguards in that's going to become inoperable.
Anyway,
Yeah.
his dog is right there.
Yeah.
I guess the snack shop and gift shop will be way down at the bottom. Wonder what they'll
Yeah.
charge. Wonder what they'll charge to climb that sucker. He'll make some money.
Oxygen tanks at the top.
If it were a modern instrument, it would have an escalator.
Yeah.
You
It's
suppose
out
the
in the
man
middle of
owns,
nowhere.
you think he owns the property and lives on it?
Yeah.
You
Yeah.
know,
Thanks, Jerry, for rebroadcasting this.
yeah, thank you, Jerry.
Yeah.
That was really nice of you to do that.
Yeah.
Okay.
I
So
gave
I
a
almost-
copy. I gave a paper copy of the original article to Chrissy, and she was fascinated. She's
Yeah.
fascinated by it. Yeah.
Okay.
Well, Star Axis, I guess, says it. If you're looking up and trying to see
Mhm.
something in the middle of that area in the middle at the top, I don't know.
Yeah.
But no hieroglyphics, right? It doesn't have any ancient
No.
Mayan.
But as Tom mentioned, that whole thing is aimed at our North Star.
That's right.
It allows you to see the procession, the way the
That's right.
stars
That's right.
kind of move in a big circle. Why our North Star at one time wasn't the North Star. It
Right.
was-
Thousands of years ago, it was in Thuban, which
There
is
you
in,
go.
is in Draco the Dragon.
Yes, when you read these enthusiasts that really don't know anything about astronomy, they claim that the pyramids are lined up with the Polaris.
No.
And they might be, but Polaris was not the North Pole star
Right. Right.
5,000, 10,000 years ago.
Yeah.
So they're just hawking their ignorance. Anyway,
Well,
Yeah.
they're super laid out incredibly well as far as right angles and other things I learned.
Yeah. Yeah.
Makes you wonder how the ancient Egyptians. Well, we got to it without Chuck, everybody. Thanks for tuning in and sharing in the Astro Hour number 284. No, this is 284, 285. Right? This coming weekend is going to be very busy. The other two gentlemen besides Jerry and I are probably not going to be part of some of it. But, well, Star Party, maybe we'll see you. Jim, Friday night, Jerry's going to talk. Why don't you show up and then support the guy?
I might do that. Yeah, I really
Take care.
I owe it to him. He does this for us every week, and Jerry
Yeah.
does
Oh,
another
yeah.
fine job.
It's a lot of work.
You
That's a
bring
great
Karen
job.
and
hey, live long and